Hello everyone. Today we shall demonstrate InstantVPN application from the Aricent SDN application suite. We are demonstrating how VPN services are provisioned in a transport or backhaul network by an enterprise customer without an administrator having to modify the network parameters manually. An InstantVPN application developed on top of Open Daylight Controller leverages OpenFlow for managing transport services in the network. So before we start with the demo, let's first understand the overall architecture and demo setup. Here we can see Aricent plugin that is developed as part of SDN controller. This provides an abstraction layer for multi-vendor SDN controllers such as HP, Floodlight, and Open Daylight. For this demo, we are using Open Daylight SDN controller that sits on top of the service provider network, comprising of the provider edges and the provider nodes. These are OpenFlow enabled OVS switches that communicate with the Open Daylight using OpenFlow 1.3. Beyond this service provider network, we have customer edges, which are simple Linux-based routers. These customer edges further have customer sites, which are distributed across different geographical locations. For demo purpose, we have simulated one host per customer site using KMO virtual machine. On top of Open Daylight controller, we have InstantVPN application, which is triggered from Aricent user interface. This is an equivalent of customer portal or BSS application where the end customer can modify the VPN settings. In this demo, we will showcase VPN creation, activation, deletion, and their corresponding behavior using chat application and accessing web servers. To verify connectivity on VPN activation, we will use chat application between Aricent sites and web server on the Frog sites. Let us now start the Open Daylight controller using this command. This will bring up an Open Daylight instance wherein we will install Aricent adapter plugin. So we type ODL Aricent adapter IMPL. This will initialize the basic network service functions like topology manager, host manager, switch manager, etc. of Open Daylight controller. It takes a few minutes to install. Now we install the Open Daylight user interface component. So now let's use a web browser to access Open Daylight user interface. So on startup, Open Daylight identifies the underlying topology that comprises of service provider network. So these are the PE nodes and the provider nodes. And now Open Daylight provisions LSP flows on each node based on shortest path algorithm on startup itself. So let's see the flows. We can see the LSP flows that have been pushed onto each node. Look at VPN application user interface and login. Let's select InstantVPN application. This GUI enables a network administrator to create, activate, and delete a VPN between different customer sites. So here we can see the customer edge list that displays customer edge details and corresponding IP prefixes. These details are extracted from a customer sites using BGP protocol and are populated dynamically. Now let's try to first create a VPN for Aricent customer. We select the sites and name the VPN as VPN1 and say create VPN. You can see the VPN gets created successfully. But at this instant, this is only a logical creation of the VPN and only the VPN tag is identified for this VPN. Let's verify the connectivity between the different hosts belonging to these sites. Let's try to broadcast and then ping. The ping also fails because there is no connectivity as of now. So now let's go back to the application and activate this VPN. We can see the VPN is successfully activated. At this instant, the VPN flows are pushed on the respective provider edge nodes and provider nodes, thus establishing connectivity. We can see the flows pushed on the respective nodes. Similarly, on the second node, we can see the VPN flows being pushed. Let's now go back and verify the same. We send a broadcast message from each host and we can see the users are connected. Also, let's ping and the ping is successful since the connectivity has now been established. Let's now go back to the application user interface and create another VPN for the Frog customer. So let's name it as VPN2 and select the Frog sites and say create VPN. We can see the VPN is successfully created. Again, this is only a logical creation and only a VPN tag is identified for this VPN. Let's now verify the connectivity by accessing web servers running at host 2 from the other hosts. We can see the server is not accessible as there is no connectivity as of now. Let's go back to the application user interface and activate this VPN. So you say activate. We can see the VPN is activated successfully. Again, at this instant, the VPN flows are pushed on the respective provider edge and provider nodes, thus establishing connectivity. We can see the flows that are being pushed. Let's verify the same. And go back and access the web servers. We can see the web page has loaded now. And we are able to access the intranet since the connectivity has established. Meanwhile, we can check the other VPN that we created is still active or not. And we ping. we can see the ping happens. Now let's try another case wherein we'll cross-check inter-VPN communication, which should not happen. Let's try to access the web server from this host. For the frog side, this is not accessible since there is no connectivity. Now let's go back to the frog sides and access the chat server. We see a broadcast and try to ping, but it fails. So let's try another use case wherein we will delete the already created VPN. So we select the VPN and say delete. We can see the VPN is deleted successfully. At this instant, the flows are removed from the respected PE and P nodes. Now let's verify the connectivity. We send a broadcast message from each host, but it fails. Also, we try to ping, and that fails too, since the connectivity is not lost. Now let's go back to the frog customer sites and see if the VPN is still active or not. We should be able to access the web server. And yes, the VPN is active. Now let's go back and delete this VPN as well. We can see the VPN has been deleted. Again, the flows should be removed. And they have been removed. So let's go back and verify the connectivity. So the connectivity is lost and we are not able to access the intranet. So we just saw that the end-to-end workflow is completely automated and there is no need for network administrator to configure the devices individually, and the impact of changes is visible almost instantly. So this concludes our demo. Thanks for your time.